What do you think the city of Atlanta, Georgia did in order to improve air quality for the 1996 Summer Olympic Games? Atlanta created a 24-hour-a-day public transportation system and closed the city's downtown to private cars. These measures had a huge impact on public health. Peak weekday morning traffic counts dropped 23%, peak ozone concentrations dropped 28%, and asthma admissions dropped a whopping 42% in the Georgia Medicaid claims file. Air pollution isn't just an abstract concept. It's a very real killer of Americans. Over half of U.S. citizens live in areas with either high ozone or high particle pollution, where the haze makes death from lung cancer and heart and lung disease more likely. Living in a city as polluted as Los Angeles is as dangerous for the heart as being a former smoker. Simply having a house near a highway increases the risk of hardened arteries by 60%. Altogether, scientists estimate air pollution kills tens of thousands of Americans each year. Ozone and particle pollution are the two chief airborne threats to your viewers' health, though carbon monoxide and sulfur dioxide are also problems. Ozone, a molecule composed of 3 oxygen atoms, is helpful to humans when found in the ozone layer, 6 to 30 miles above Earth, where it shields us from ultraviolet radiation. But when created by the reaction of combustion products with sunlight and heat near the ground, ozone can provoke coughing, inflame the throat, and make it harder to breathe deeply. Ozone may also lower resistance to respiratory diseases like pneumonia, permanently damage lung tissue, and aggravate chronic lung diseases like asthma or bronchitis. Children and those with pre-existing lung disease are most sensitive, but even healthy adults involved in moderate or strenuous outdoor activity can feel its effects. Particle pollution, on the other hand, tends to provoke heart as well as lung problems. It's made up of tiny pollen grains, mold spores, organic chemicals, metals, dust, dirt, smoke, and liquid droplets smaller than 10 micrometers. They are often referred to by 2 names, PM 2.5, which are particles smaller than 2.5 micrometers wide, and PM 10, particles which measure between 2.5 and 10 micrometers. PM 10, or coarse particles, tend to come from crushing and grinding operations or dust stirred up on roads. PM 2.5 is formed by combustion, mainly in cars and plants, but also in fires or volcanic eruptions. Smaller particles are more dangerous because they penetrate farther into the lungs. Particles can worsen air quality both indoors and out. They are especially dangerous to those with heart or lung disease, to exercisers who breathe in many more particles when exerting themselves, and to children who spend a lot of time playing outside in summer. Short-term exposure can cause breathing problems, asthma, and heart attacks. Long-term exposures can produce chronic bronchitis, permanent lung damage, and premature death. Carbon monoxide, another pollutant, is an odorless gas produced, in part, by the incomplete combustion of fuel. Vehicle exhaust contributes about 60% of all carbon monoxide emissions nationwide, and up to 95% in cities. Carbon monoxide is dangerous because it binds to hemoglobin in red blood cells, choking off the oxygen supply to organs and tissues. Those with pre-existing cardiovascular diseases are most at risk, but carbon monoxide can impair mental alertness and vision even in healthy people. Particle pollution tends to worsen in winter, although it can be high any time of year, while ozone peaks on still afternoons in summer, when cities are bathed in warm sun. Carbon monoxide is worse during rush hours and in winter when cold weather makes combustion less efficient and inversions trap pollutants near the ground. Though people may believe there is no way to avoid air pollution, they can actually reduce their exposure by simply checking the air quality forecast you provide and using it to plan their strenuous outdoor activities. The Air Quality Index, like the UV Index, is available to help you alert your viewers when the air is unhealthy. You can find graphics, explanations of, and talking points for various index numbers at airnow.gov. What do you think? What is the main factor contributing to flu transmission in the winter? In October 2007, researchers finally demonstrated why flu season is in winter and not summer, and why there is no flu season in the tropics. It wasn't crowding, or coughing, or even that cold weather weakens immune systems. Winter weather, it turns out, helps flu virus particles survive in the air. Flu virus is spread through tiny liquid droplets exhaled by sufferers. Coughing and sneezing aren't necessary, although they certainly help. Researchers have discovered that the virus survives best in dry, cold air. 41 degrees Fahrenheit, or 5 degrees Celsius, and 20% humidity were ideal for transmission among guinea pigs. Transmission stopped entirely at 86 degrees Fahrenheit, 30 degrees Celsius, or 80% humidity. The virus particle coats seem to be more stable at cooler temperatures, and drier air keeps the liquid droplets that contain them aloft longer. Colds, unlike flu, are spread by touching surfaces contaminated by cold viruses or by shaking hands with people afflicted by colds. Wives' tales have long held that cold weather brings them on. But is there any truth to that? Evidence is mixed. In one study, people who sat in cold rooms shortly after being exposed to colds didn't get any more or fewer colds than those who sat in warm rooms. But in a separate study where people were not exposed to cold viruses by the researchers, 29% of people whose feet were simply plunged into cold water developed sore throats and runny noses within 5 days, while less than 10% of those kept warm did. Weather can also affect populations of mosquitoes, ticks, and mice, which transmit disease. Warm winters with abundant snow and rain help these animals survive the winter and produce ample food for them come spring. Ticks, which can transmit Lyme disease and Rocky Mountain spotted fever, thrive in warm, moist weather, but don't do so well when things dry out. Deer mice carry hantavirus, which is transmitted to humans aerially when mouse droppings are stirred up. In 1997 and 98, El Niño produced a warm, moist winter in the southwest U.S. that was blamed for a subsequent deer-mouse baby boom. The effects were felt the next year, when in 1999, public health officials counted 18 suspected or confirmed cases of hantavirus pulmonary syndrome during the first 5 months, compared with an average of 2 cases during the same 5-month period from 1995 through 1998. Extreme weather conditions like drought and flood also promote mosquito outbreaks, and many have been to blame for the severity of several West Nile outbreaks across the country. Weather-related seasonal pollen and mold can provoke allergies among your viewers. 10% of Americans suffer hay fever from pollen allergies, making it the 6th leading cause of chronic illness in the U.S. In addition, 9 million children and 16 million adults suffer asthma, which is often linked to allergies. In nature, pollen grains fertilize plants so they can make seeds. Some plants use wind to distribute them instead of insects or birds, and it is these wind-borne spores that cause people problems. In the spring, trees are the source of most allergenic pollen. In late spring, grass pollen predominates, and in late summer and early fall, weed pollen is abundant. Allergies are worse during hot, dry, or windy days, peaking at midday in cities. Pollen counts are lowest during chilly, wet times. Sharing pollen counts with your viewers can help them stay healthier if they avoid spending time outdoors on days with high counts and use air conditioning set to recirculate. Molds can also trigger allergies and asthma in susceptible people. Mold spores are naturally present in low concentrations in all air and are generally harmless. Though there are many types of mold, none will grow without moisture. But after heavy rains, when field and forest fungi flourish, or when condensation, leaks, or flooding dampen homes, dormant spores can grow explosively and release enough new spores to sicken sensitive people. During these times, the affected may experience congestion, throat irritation, coughing, wheezing, red eyes, skin rashes, or asthma attacks. Allergies are by far the most frequent illness associated with mold. More severe illness, like fever or a fungal lung infection, are uncommon. When seasonal mold spores are a problem, sensitive people should avoid compost piles, cut grass, and wooded areas. It's impossible to get rid of mold spores indoors. Instead, keep cloth, paper, and wood products in the home dry. To do this, keep indoor humidity no higher than 60%. Dehumidifiers and air conditioners can help, as may open windows. Properly ventilate shower, laundry, and cooking areas, and make sure the exhaust fans empty outside, not into the attic or other interior space. If it's already too late and mold has grown, viewers should clean it from hard surfaces within 48 hours if at all possible, with soap or detergent and water. or a solution of 1 cup bleach per gallon water. Remove or replace any soaked carpet or upholstery that can't be dried in 48 hours. In addition, homeowners must also promptly fix leaky roofs, windows, pipes, or other sources of moisture that may have caused the mold problem in the first place. Floods and wet weather put your viewers especially at risk, so make sure you remind them during these times to dry out soggy homes as soon as possible.